Welcome to composite functions. Now you may have seen this before in another math class or programming languages or something like that, but this might be new for some of you, so heads up, and that's why I drew everything out. Composite has nothing to do with inverse. I don't want to make sure that you get balled up with this particular image here, because yes, you are going to get at least 3 sets, but notice I'm applying a different function called g onto f of x in order to get my newest results in my z-domain set of values. So notice our normal, if I put my hand here and covered that up, notice my normal f of x to get my new values in a set of y, but I'm applying another function to those values in order to get a new set of values from there. So what it's going to look like, and then mathematically we'll talk about it here in a second, is that it's going to look like we're going to apply the function f to get our values y, and then we're going to apply our function g to get our values in set of z. What the composite's trying to do, it's still going to do the 2 steps, but it's going to write it as one. Notice that we're going to have to go through the different steps in order to do that, in order to reach from our y to our z. Now what's going to happen here is that order does matter. This means that I'm actually going to take care of f first. Now you're probably like, what the heck? Notice parentheses. You and I love parentheses, right? G is going to wait for f of x to complete first, because f of x is physically inside of those set of parentheses, and that's going to take care of our x to y transition. So we're going to do that first. And then once that's done, then we'll go ahead and complete the transition all the way from y to z using our g function from that. So in reality, I'm still reaching, well, exactly what I was hoping for from y to z in our different set using our composite. What does this look mathematically that we've gotten over the theory here? I want you to notice that these 2 sets of functions that I have for f of x and g of x, there's no logical thing to them, there's no particular order to them or anything of that nature. There may be in a real-life application, so I just want to make sure this is perfectly clear. This is really just going over the logistics of where it gets plugged into what. So that's why I have some highlights in here, but also notice it's 2 different directions. We have f is a composite of g, and then g is a composite of f. So 2 different directions happening here. Now, when I look at the first line here of our f composite of g with the value of 1, it looks like I'm doing f function first, but it's really not. Notice that 1 squared minus 2 is really coming from g of x. I'm really taking care of g of x first. So 1 squared minus 2 equals negative 1. So notice now that I've done everything inside of those parentheses that was g, now I can follow up with f with a negative 1. So negative 1 plus 3 equals 2. So notice how that's set up. And notice how the order is different from the next one. The overall setup looks very similar, but the order is very different. G, I take care of 1 plus 3. Where did 1 plus 3 come from? That actually came of f of x first, where I placed in the 1, took care of that, equals 4. Now I can take care of g because f of x is taken care of. There's 4 squared minus 2, which equals 14. The 2 items that are in the middle are just using x to basically show you, if you just used a variable x, on how that would be sorted out. But notice the overall setup would be the same, and the values would be the same if we put in the 1 for both of them. It just helps us kind of formulate things a little bit nicer. So this would be the shortcut if we had a lot of variables that we really wanted to use for this. So that's where we can use the shortcut, or if we're given a particular value, we can go the long way. Either one is just fine, depending on the situation. Finally, there are other important functions that the book goes over that frankly we should have already had experience with that I'm not going over. Floor, ceiling, and factorial. Now, if you need help with that, let me know, and I'm happy to give you some materials on it, but frankly, a lot of us have done this already, but let me know, and I'm happy to help you, but I'm not going over that in this particular set of videos.